Well, this next video segment, I'm going to demonstrate how to work through a data representation passage. And so when I flip to, this is practice test 1 that I gave you in the packet. This is the first passage here. One of the things I recommended in my first video was to recognize a data representation. So first of all, you can see that there's a couple of tables here, but one of the telltale signs is there are 5 questions. Only data representation passages include 5 questions. So these are the ones I recommend that you do first. First of all, because there's only 5 questions, you'll go through those a little quicker than the other 2 types, but also they just tend to be a little bit easier. So what I'm going to try to do is pretend like I'm actually taking this and see if I can work through these 5 questions in the 5 minutes that I suggest for each passage. And then you can kind of listen to the logic and the reasoning that I do. So I'm going to do all of my thinking out loud so you can kind of understand how I approach this kind of thing. So one thing I'll recommend is before you ever sit for the real test, just read through the directions on a practice test. These are never going to change, and there's really not much included in here that you wouldn't know logically. It's just making sure that you answer all the questions and that you know that each question goes with the passage before it and things like that. So let's start the time now. So when I get to this passage, I'm not going to actually read everything, because as soon as I can see that there's astronomers and planets, and I know I'm talking about an astronomy question. I just have that in my frame of mind. And now I'm going to look at these 2 tables, and I can see that there's different kinds of planets, and then over here there are 7 different planets. There's always a situation where we're going to tie these things together. So I don't need to know the details right now. And I'm not going to read all the passage. I'll get to that if I need to. The first question says the data in Table 1 and Table 2 support which of the following statements. So I'm going to make sure I pay attention to both tables. So I'm asked about which classification goes with an orbital radius. So just process of elimination. This says gas giant planets have the largest orbital radii. Well, orbital radii I don't see anywhere over here on Table 1, but I do see it here in the last column on Table 2. So the ones with the largest orbital radius is the Gliese 777 and Gliese 581, and those are definitely not the most massive ones here. So, or gas giants. Sorry, gas giants are Gliese 777 and Ogle TR, and Ogle TR is not among the largest Earth radius, so that one is not supported. Orbital radius is directly related to mass. Now I'm looking on these tables and I see that orbital radius and mass are next to each other, but I do not see a correlation. The one with the biggest mass does have the biggest radius, but this one with the next biggest mass has a very small radius, so that one's not supported. See what I'm doing here with my pencils? I'm crossing things out and underlining and circling to help me keep track of stuff. Orbital radius is inversely related to mass. Again, I don't see that relationship in these 2 columns. The data does not support a correlation between mass and orbital radius. That's the only one I can see that is supported by this. According to tables 1 and 2, which of the following stars has the most massive gas giant planet orbiting it? Okay, so the most massive gas giant. So here are my gas giants. They are Ogle TR and Gliese 777, and this Gliese 777 is the most massive. Which of the following stars has it orbiting it? So the star that the planet orbits, Gliese 777. And so that is F. Didn't even need to read the rest. If a new planet were discovered with a mass of 325, an orbital radius of 1.5, and a composition of mostly hydrogen, what would be its most likely classification? Well, I noticed the classification is not really in Table 2. It's over here in Table 1. So the size and the orbital radius do not have to do with the planet classification. So I'm looking for the one composition of mostly hydrogen. So here's one, gas giant, and I don't see any others that have hydrogen included in composition. So I'd be looking at gas giant, which is D. Number 4, all of the following are true about the star Gliese 581 except what? So I'm going to see 581 here, and I'm going to see 581 in these 2. So let's focus on those. has multiple planets orbiting it. Well, Gliese 581 is orbited by both planets 2 and planet 3, so that one is true. Now, notice I'm looking for all the ones except, so F is not one of them. 581 has the most massive planet orbiting it. No, the most massive planet is 777, or the orbiting star 777. So that's not it either. Gliese 581 has planets orbiting it that are classified as water. Well, the ones orbiting 581 classified as water, 581, that sure looks like the one. So that is an exception. And 581 has only planets with masses less than 50 Earth masses orbiting it. So 581, the planets orbiting it, one has a mass of 20, one has a mass of 10. So both have a mass less than 50 Earth masses. So J is the correct answer there. And the rocky Earth planets in Table 2. Now what would those be? The rocky Earth planets are orbiting Kepler 11 and HD. So Kepler 11, I got enough marks on here. I'm going to mark this one differently. So I put a little line next to it. And HD 69830, that's not on here. So this says, have what in common? Okay, so their masses are less than 20 Earth masses. That's true there. They're only found in deep space. I don't see anything here about what deep space is. And I'm looking quickly through here. Did I miss something about deep space? Don't see it there either. So I don't know anything about that. Hydrogen is a major component of the crust. Well, those hydrogen ones, those are the gas giants. They're orbiting those two things. That doesn't seem to fit. Their orbits are less than 1 Earth radius. So again, we're talking about here. The orbit is 3.5 Earth radius, so that's not it. The mass is less than 20. That's the only one that I see that is actually supported by this, and so that's answer A. So now I haven't looked at my time, but I think I'm close to 5 minutes. So remember, the suggestion I gave in the first video is if I get to 5 minutes, I'm just keeping an eye on the clock, I may want to answer 4 of these, and unless I'm a good distance through number 5, I'm going to maybe stop and move on to the next passage to try to answer what could be easier questions in the first part of that. So hopefully this little demonstration was enough to give you a little confidence that you can do these in 5 minutes. I'm not an expert at astronomy, and I've certainly not seen this kind of passage before, and so it's very similar to the scenario you'll be in on test day. So practice these things, build up your confidence, build up your quickness in this, and I think you'll find on test day you'll be more than ready to go. Hope this was helpful. Thanks for watching.